Alright guys, this is Miss Katzman here, and in this video today we're going to be looking at the inverse of quadratic and cubic functions. And we're also going to verify that they are inverses. So first, let's do a little bit of reminder on information you already know about inverses. So let's look at our first function here, which is f of x is equal to 2x plus 3. You can also write this as y is equal to 2x plus 3. They're the exact same. Now I want you to pause the video and tell me what is the next step you need to take in order to find the inverse of our original function. So pause the video real quick. Alright, so hopefully you've thought about it, and this is how we find the inverse. So the first step we need to do is we need to swap the y and the x variables. So we write that over here as x is equal to 2y plus 3. Now that's the first step. Now pause the video again and solve for the inverse from here. Alright, now I'm going to work out the rest of the problem. So here's our next step. Drew a little arrow. So next step, we're going to solve for y. So we start by doing x minus 3 is equal to 2y. Sorry, it's a little sloppy. And last but not least, you divide by the 2. So we have x minus 3 divided by 2 is equal to y. There we go. And x minus 3 over 2 is equal to your inverse function. Now you can also write the inverse, sorry, little side note over here. You can also write this as f of negative 1 x is equal to x minus 3 over 2. They mean the exact same thing. Okay? Alright, now we're going to start looking at the composition of functions. So, let's do the notation first. So the notation for compositions, it would be f of g of x, other parentheses, and you can also write this as f, oops, forgot a parentheses right here, and then you put a circle, which is supposed to be of g, parentheses, x. These are the exact same notation. These mean the exact same thing. F of g of x is equal to f of g of x. Alright? So now, let's do a substitution example. So, f of x is equal to 2x plus 3. And then we have g of x is equal to x squared. Now, pause the video using the information you have above and plug in, or using, okay, taking your functions f of x and g of x, plug them in to the notation above. So pause the video and do that real quick. Okay, hopefully you figured it out by now. So let's do f of g of x. So first you would take your f of x function, so you'd have 2, and then you plug in g of x where the x is in your f of x function. So the way you would do that is 2 times, oops, 2 times x squared, close parentheses, plus 3. And that is how you would write f of g of x. Now let's do g of f of x. So then we would have g of f of x. Now using the same principle, plug in g of f of x. So since g of x is x squared, you would just plug the entirety of f of x, which would be 2x plus 3, in parentheses, to the second power. And that's g of f of x. Fairly simple. Okay, now we're going to apply the information that we learned on the previous slides and put all of it into one example. So using the previous functions of f of x equal to 2x plus 3 and its inverse, which would be the inverse of f of x is equal to x minus 3 over 2. So now, that's going to say x is equal to 4. So first what we're going to do is plug 4 into f of x. And we get 2 times 4 plus 3, which is going to give us 8 plus 3, which will give us 11. So now, taking this number here that we got for f of 4, we're going to plug the 11 into, I'm going to plug 11 into our inverse function. So the inverse of f of x, when it's equal to 11, so you do 11 minus 3 all over 2. And on the top, you would get 8 divided by 2 is equal to 4. Now look at that. So by plugging in the value that we got by plugging in our original x value into our original function, and then plugging in this value that we got into our inverse function, we ended up getting our original x value. Pretty cool, right? And the way we would write this is f inverse of f of 4 is equal to 4. So once again stating the rule, so applying a function f and then its inverse f of negative 1 gives us the original value back again. Now this principle also works going in the opposite direction. So we'll do f inverse of 11 is equal to 11 minus 3 over 2. And once again, you get 8 over 2, which is equal to 4. So now we plug in this value we got here back into our original function. So we have f of 4 equal to 2 times 4 plus 3. So you would get 8 plus 3 is equal to 11. And look at that, it worked out. So then we would write this as f of f inverse of 11 is equal to 11. And from this information that we have acquired here, we can confirm the rule that f of f inverse of x is equal to f inverse of f of x, which is also equal to x, your original x value. Make sure you write this in your notes. It's very important. Okay, now we're going to do one last example before we end the video. So the function we have here is f of x is equal to 3x minus 1, which can also be written as y is equal to 3x minus 1. Now pause the video and find the inverse of f of x for me real quick. Alright, so you should have found the inverse already, so I will show you how it's done. So we swap the x and the y, so it's x is equal to 3y minus 1, and then we get x plus 1 is equal to 3y, and then divide by the 3, so you get x plus 1 divided by 3 is equal to y. Same thing as writing it equal to f of negative 1 of x. Alright, so now let's plug in an x value. Let's do this in a different color. Of x equal to 2. So, just like we did before, we're going to have 2 plugged into our original function. So it would be, equal to 3 times 2 minus 1. So you would get 6 minus 1, which is equal to 5. So now plug in this value right here into our inverse function. So then we're going to have f inverse of 5 equal to 5 plus 1 over 3. And we'll get 6 divided by 3, which is equal to 2. And that's the same as what we got, or it's the same as our original x value.